All right, welcome to Unit 6, Lesson 4. We're just moving right on through this material. This is on natural exponentials and logs. It's going to embed an activity. So if you're doing this from home and you're not present for the activity, I'll try to do my best to summarize that for you. It does tend to be a shorter lesson, and usually nobody complains about that. It builds very naturally on the last lesson, which was on the longer side. Now, I like to start this particular lesson with a review of what we've covered thus far, just to kind of recap, where are we in our study of exponential equations and how to solve them. So one of the first things we did was we covered this first strategy, which is to write each side as a power of the same base. So when you're looking at this problem right here, you can see you've got like 5 to the x plus 1, and then we have the square root of 5. And for most people, when you look at that, the 5 kind of jumps out at you, like we have a 5 on both sides. So that particular strategy would be if we could get, say, 5 to the something equals 5 to the something, then we could set those two somethings equal to each other. So the issue with this problem that's a little bit different is the square root. And we have covered this. Okay, this is review, but it's been a little while since we've looked at it. So this is one of those things that you might not think to do on your own, but when I do it out and you're like, oh yeah, that's right, I remember seeing that. And then hopefully the next time you see it, you'll remember that there's a way to do it. So we don't need to mess around with the left-hand side of that. And I'm moving my hands around here to the left-hand side as though you could see. I guess that's what the pointer is for. Over here on the left, we don't need to mess around with that, but we do need to alter the square root of 5. We need the 5 outside of the square root. And so I'm going to go ahead and copy down 5 to the x plus 1. And then you might remember from an earlier lesson, not long time ago, that was third quarter, we had this way of taking anything that was a radical and writing it as an exponent. And we would do it this way if you had something like a and I don't even know what, like x, y, I don't know, I'm picking letters here, that would be a to the y over x. So the index of the radical would become the denominator of the fraction, and then the exponent would become the numerator. And you could do that with any radical at all. And in that unit, I said, if there's one thing you remember, if there's one thing you take away when it comes to rational exponents, it's the square root. The square root is the equivalent of an exponent of 1/2. And the reason why that's the kind of this one thing, just one thing that you walk away and you kind of keep in your head long term, it's because square roots are the most common radical that there is. You're going to see a lot more square roots than you're ever going to see cube roots or fourth roots or anything like that. So that's the little nugget of information from a previous lesson that you would need. And now this strategy works the same way it did a couple lessons back, where you could set the two exponents equal to each other. And you are welcome to use a fraction here if you would prefer to use a decimal. Desmos will handle the fraction arithmetic for you. So if you want to use the 1/2, that's not a problem. And then we would subtract the 1 from both sides, and we get x is equal to negative 0.5 or negative 1/2 if you kept it as a fraction. And with any kind of decimal that ends, it's usually not an issue. So 0.5, 0.25. It's the ones that don't end. It's like your 0.6666666. Then you end up having to round, and mathematicians are going to shy away from that. But as long as there's no rounding involved, usually it's no issue. Okay, last lesson we covered this situation here where you've got a base and it's not possible to write each side of the equation as a power of the same base. And when that happens, we need to engage what's called a logarithm. Now, the steps, if you don't know the steps or you haven't watched this, been through the last lesson, you need to go back and watch that lesson. Make sure you go through the process and the steps on that. But the first step is to isolate the exponential. So the exponential here is 6 to the 2x minus 1. It's going to be the base and the entire exponent associated with that. So this negative 2 here, we do not want. And we cannot multiply them Okay, we have order of operations. Order of operations says we do the exponent before we do the multiplication. Only the 6 is being raised to the 2x minus 1, not the negative 2. So if you were to try to multiply them, then you would be taking the 2 and also in some way raising it to that power, and that would not be correct. So the way we're going to get rid of that negative 2 is we notice that this is multiplication, and we can undo multiplication with division, and we just make sure we divide both sides. So we get 6 to the 2x minus 1, and then a negative divided by a negative will give us a 5, positive 5 there. Now we would write this as a logarithm. So pretty much we've done everything that we can do with it as an exponential. So we will write this as a logarithm, and this would be written as log base 6 of 5 equals 2x minus 1. You can use Desmos and put in log base 6 of 5 and get the decimal. Or if you are using not Desmos, which I'm not at the moment because I'm stuck in a PowerPoint, we can use the change of base formula, which would give us what I call the log of the attic over the log of the basement. And then I need to grab my calculator and put that in. So clear that. So I have log, what do I have there? Log of 5 divided by log of 6. I did not mean to do that. That was silly. And I have 0.8982. And that's equal to 2x minus 1. And now I'm going to need to move over. Now, I am running out of space there. I kind of wrote that really big in the middle. Sorry about that. But when you need more space, try to move in an orderly way. So I'm going to move to the left, and I'm going to go back up to the top and start working down again. I'm not going to move like this and then put an answer over here or anything. So we want to try to keep it user-friendly as much as possible. So we have 0.8982 equals 2x minus 1. And I'll add 1 to both sides. So we will now have 1.8982 equals 2x. And then divide by 2. And I will need my calculator for that. Plus 1. Divide by 2, and I have 0.9491. And just to make sure that's clear, I am going to box that answer in. I am trying to model that, and I apologize for getting that all kind of crowded in there. That's not my intention. I do try to keep my work laid out nicely, but it is hard on the PowerPoint slide sometimes. And just when it happens to you, and it does, we just run out of space, so we misgauge how much space. Remember, you're working from top to bottom, left to right. So you want to try to keep that work in an orderly fashion as much as possible. Okay, so that's a review of what we covered thus far. That took a little bit less than 8 minutes. Because I can see the total slides on here. Just kind of reviewing the last couple lessons. Hopefully that worked as a nice refresher if you were absent or just needed to remember how to do those problems. All right, now this is where in class we are going to do an activity. And we're going to discover E. You might have noticed in your journeys through mathematics that E is almost never used as a variable. We use lots of X's, lots of Y's. N's are common. We'll see stuff like A's and B's and C's on occasion. We'll have like those kind of variables, but you almost never see an E. And there is a reason for that. It is because a lowercase e actually represents something else in math, something really specific. So here's how the activity works. Everybody in class, for those of you that are not going to be in class, is going to get a grid. And on that grid are the numbers 1 through 64. Okay. So it's like an 8 by 8 grid, so I didn't do a very good picture there, but the numbers 1 through 64. Then you're going to go to random.org, which is a random number generator. And that is a whole interesting concept in and of itself. In my digital electronics classes, we actually design a random number generator. Like, how do you come up with a device that generates random numbers? And you're going to set the limits for 1 and 64. So it won't pick anything lower than a 1 and nothing higher than a 64. And then begin generating random numbers. As you get numbers, you're going to mark them off on your board. So you're going to do random number, and let's say you get a 7, you're going to mark off a 7. And then you get a 4, and you mark off a 4. Now, you're going to repeat that a total of 64 times. So you're going to run that random number generator 64 times. It'll be beneficial if like one person at your group is tallying up how many times you're clicking that. Now, if you mark off like a 7 and then you get another 7, it gets already marked off. You can put another X over it if you want, but you don't have to. And then you're going to go 64 times. Then you're going to count up the number of unmarked spaces that you have. So you kind of get all the way through, and you're going to count up everything that doesn't have a mark on it. And you're going to take the ratio of total squares, which is 64, to the number of unmarked, and you're going to get that decimal to 3 places. And then I'll have a spot on the board where you can write what your ratio and what your decimal are, and we're going to average them together. So if you have a copy of the notes outline, you'll notice that there's a spot for that. Now, what's really cool about this, and this is just kind of an interesting activity, is that pretty much everyone in the class is going to come up with about the same ratio, and that ratio is going to be equal to this number E. Okay. And so the more trials that we have, the better it goes. So the more groups we have in a class, the more, if we can average different classes together, the more trials you have, the closer and closer and closer you're going to get to this number E. So what is E? E is this number that turns up in nature. Okay, it's just there. It's kind of like the number pi. When you are dealing with circles, if you measure a circumference and you measure the diameter and you take that ratio, it always seems to come up close to the same number. Now, pi is irrational and so is E, so you're only going to get an approximation of it. But E just turns up in places. It turns up apparently on grids of 64 with random numbers being picked. It turns up in money. It turns up in your financial world. There's a formula for interest that your bank probably uses, and E shows up in that number. It just shows up places. It shows up in oh gosh, I used to teach a topics in math class, and we would do problems that involved like radioactive decay. And the number E just shows up. So what is it? It is just a number. And let me get it up on here. We're going to do E. E is approximately equal to 2 point. That is a terrible 2. Really? All right. 2.71828, and then it goes on and on. So it's really just a number, and that's about what it equals to. Just like pi has its own symbol, and it's about equal to 3.14159, and you just kind of decide how many decimal places you need with it. You can do the same thing with E. Now, if you've got a calculator, you'll notice that there is an E button on the calculator. On Desmos, you can just type in a lowercase e, it'll recognize that. So when it's used as the base of a logarithm, it gets its own symbol. So we've dealt with logs, and we've had like log base like 5. We've got log base 10, which is the common log, and you don't have to see the base. If you have log base E, so it's log base 2.71828. it gets its own symbol, and its symbol is, I'm doing well today. It's actually evening. It's been a long day. So is that it is an LN. That is L. This is an L, not an I. Okay, I've got that in nice big letters there. This is an L, not an I. It is an L for logarithm, N for natural. Okay, natural logarithms, or logarithm naturel, which is what a large chunk of the world would say. But in English, we put the adjective first. So we say natural logarithm. So it's ln. Every year, I will have students put an I there, and they will tell me that this is something like an inverse, which I never say in class. That's what it is, and never will, because it's not. It is a natural logarithm, and it's simply a logarithm with a base of e. Most calculators will have its own button for a natural log. So you'll have a button that says log, which is your common log, and then you'll have another button that says ln, and that is your natural log. Here's the good news. Everything else that we have covered about logs is exactly the same. So that's it. That's all the new information is. Hey, there's a special kind of log that has its own base, and literally everything else that we have covered about logarithms is exactly the same, which is why this lesson tends to be a little shorter. So here we do some example problems here. So we have this equation, 4e to the 2x plus 2 equals 16. As with our other logarithmic equations, we do want to isolate the exponential. So the exponential here is e to the 2x, not 4e. The 4 is not being raised to the exponent. That's your order of operations. The exponent happens on the e before the multiplication on the 4. So it's e to the 2x. So we need to get rid of the plus 2. We need to get rid of the times 4. And the way that we will do that is by subtracting 2. So we will have 4e to the 2x is equal to 14. And then we will divide by 4. And it's because that's multiplication there. And you are welcome to change this to a decimal if you want. I think I'm just going to simplify. Well, I think it's just 3.5, right? Yeah, I'm pretty sure it's like 3.5. We'll go with that. Okay. And now, just like with the last lesson, the next step is we will change this over to a logarithm. And so in this case, it would be log base e of 3.5 equals 2x. Now, I did that in a different color because really, we don't want you to write that step. Here's what we want you to write. Log base e has its own symbol, and that is ln. Okay, so I'm doing that in a different color just to kind of highlight it. It's not incorrect to write that, okay, because that's what natural log is. It's log base e. That's what it is. The reason I tend to write that is because I want to tie this into the previous lesson. I really want you to see that there's not some weird natural log voodoo happening. It's the same process, just with an e there. And then because it is a special log, it gets its own own symbol with the ln. Really, though, what teachers are going to want to see is you're going to want to see that you are going straight, between those orange lines. I will not take off anything if you show that middle step. In fact, I would rather you show it and understand what you're doing and how the symbols are changing than to just start skipping steps and not know what's going on. All right. So now there's like a couple things I want to point out here. I'm going to do something here that I wouldn't normally do. Actually, maybe I'll do it twice. So when you have the ln of 3.5, what's good about that is that you don't need to do the change of base. So you can actually just type that into your calculator, natural log of 3.5. I'm going to copy that right here. Okay, I'm just going to copy it. And that is 1.2528. And then you would divide by 2. And that is 0.6264. Okay. Now, what I do want to take a moment and point out is sometimes, and this will happen on multiple choice tests, is people will ask for the exact answer. And what they mean by that is they mean when we did this step right here, we rounded. Our calculator gave us a much bigger, like longer decimal there. And we rounded, which means that this is really just an approximate answer. And so here's what we would do if you were asked for an exact answer. You would just go ahead and divide by 2, and then you would leave the answer just like that. Okay, so it's pretty much the same thing, except you don't, what we would say, evaluate the logarithm. So you just leave the answer in with the ln of whatever it is, and then you just kind of work the algebra around it. So you just say, okay, I'm just going to divide by 2. And then you can't divide 3.5 by 2 because the 3.5 is like stuck inside that natural log. It's not 3.5 divided by 2. It's the natural log of 3.5 divided by 2. So you would just leave that. In a lot of ways, the exact answer is easier because you don't have to grab your calculator. You don't have to put anything in. You don't have to round it. You can just leave it as is. But sometimes students are thrown off a little bit by the directions on that. Like, oh, what do you mean exact? So that's what that means, is you just avoid the step that has the rounding. Here's the second example. So this is e to the 3 x over 3 plus 3 equals 15. And so I just wanted to tackle that. It's just the exponent looks ugly. The exponent is a fraction, but we just remember math is consistent. We know math is consistent, so we don't need to freak out about it. And we're going to get that exponential by itself. So we'll go ahead and subtract the 3. And now we change it to a logarithm. So we've done everything we can do with the problem at this level. So this would be, I was going to do this in a different color. This would be log base e of 12 equals x over 3. But we don't really want you writing that. We really want you to just write natural log of 12 equals 3 and go straight to that abbreviation, that ln. Write log base e for as long as you need to reinforce that changing over of the form and what the natural log is. Okay. Again, no pressure from me. I just want to make sure that it's clear. Like if you do that in another teacher's class, they might not like it. All right. And then we would evaluate the natural log. So this is natural log of 12 is x over 3. And I type into my calculator natural log of 12, and I get 2.4849. And then we say to ourselves, okay, what is the operation happening? Well, we know a fraction bar is division. How do I undo division? I undo division with multiplication. Just make sure you multiply both sides. So I'm going to multiply by 3, and we get 7.4547 equals x. And then just for that contrast, again, if somebody were to ask you for the exact answer, what you would do is you would multiply by 3, and you just would skip the step where you evaluated that log. Okay, so you would just skip the natural log of 12, changing it to a decimal, and you'd go right to, oh, okay, I multiply both sides by 3, and that is your exact answer, just meaning there's no rounding involved in that answer. Okay, and you might see multiple choice questions on your EOC or on the SAT where the answer choices are given in exact form. So it's good to know what that is and be able to navigate your way back through it. Okay, that's pretty much the lesson. So the practice, which is to be done on separate paper to turn in, You've got some equations there. I copied this from an older set of notes that I have. I didn't double check my answers on this, so I could photo math them right now, but hopefully those answers are right. Somebody will let me know in class if I've copied something wrong. But that should be turned in on a separate piece of paper. So if you're doing this from home, you can absolutely participate in that and turn that in. Make sure you do the work yourself, though. Don't photo math it. The answers are there, not so you can turn in the right answers. The answers are there so that you can know if you've understood the lesson and are able to carry out the steps, and to give you that assurance. If you're not getting them right, it doesn't mean photo math it and turn it in and get a grade. It means ask a question. That's what it means if you're not getting them right. So feel free to pause there and get the practice work in. And then the last slide, the homework is on your notes handout. And for those that are in class, that's not an issue. There's an issue with the printer. Getting stuff printed out. So I basically copied all of that off of a worksheet and put it onto your notes. But if you are doing this from home and you don't have a copy of the notes, you still need to know what the homework is. So the numbers got caught off the side a bit there. So the first question is, what number is E approximately equal to? Hopefully you were taking notes. Rewind the video if you weren't. What does ln stand for? What is the base of the natural log? Those are all in the next one. So question 4, parts A, B, and C. In the expression 4e to the x plus 2, identify each of the following: the base, the coefficient, and the exponent. Those first 4 are like low-level vocabulary kind of things, like what do the symbols stand for. And question 5 is this one right here. It's identify the mistake in this work. So the numbers again got cut off. So it's 1, 2, 3, 4. This one is 5. And just kind of take a look at the work and identify what's wrong. There is a mistake. And then 6 through 10 are just equations to solve over there. So it's 10 problems. And if you have any questions, let me know. Was a short lesson. It's 27 minutes with the summary of the homework. So as always, you guys know where to find me. Let me know if you have questions, and I will see you next time.